I am, aren't I? Same thing as yesterday, kind of, but the opposite. I'm going to give you the derivative graph, and from that you need to find f. Or, hopefully, I'm going to give you guys the second derivative test, or second derivative function, and you're going to graph the original from there too. So, that's our goal. Let's begin. And I'm back to all my normal software, so we should have a nice, easy day with no crazy things.
Sometimes I start using Greenland just to get that.
Guys, doing that paper on your desk and pass the title slide. You guys should be writing this down. We're on example 1, homies. Alright. So, what is this a graph of over here on the left, you guys? F prime, which means it's the what of what? Good, it's the rate of change or the slope of f. So if this is the graph of f prime that represents the slope of f, then what do I know about the slope of f? It's positive and it's constant. What does a function with a constant slope look like? A diagonal line. And it's positive too, so which way is it sloping? Upwards. So we have no idea where this thing is. Okay, it could be here. It could be up here. We don't know where it's located. Remember how when you integrate, you go from a derivative to original function, you always get a plus c? You have no idea how high or low that function is. All you know is what the general shape is. So, we don't know where it is, but we do know that it is it's a constantly increasing function. All right? Let's go ahead and move on to another example. Well, I don't know. I'll be nice. I'll slow down because I'm afraid the next one might throw you guys a little bit.
So is this a student practice?
Yeah. Go ahead and give me a graph of f. Go ahead. Go ahead. So there's our answer, guys. He's got it correct. It's going to be a straight linear function because the slope on the left is a constant slope. And it's also a negative slope, so it slopes downwards. Let's go ahead and move on to another one. This is where things begin to become a little more interesting. Example 2. Yes.
Can you just do the lesson in that accent you were doing earlier? Can you please?
I don't know. I think it'll be distracting, honestly. I don't have style sense, so it's probably cool. Okay, so guys, check this out. This is where things get interesting, so pay attention. This here is a graph, once again, of f prime. Okay, so what do I know about f prime at this point?
It's negative.
Not hearing the right answer?
It's
No?
Wait,
Okay, so what do I know about f prime at this point? So x equals 2, yes, but what is f prime? It's 0. Maybe it would help you if I wrote it like this. F prime of 2 is 0, right? Now, when f prime of 2, when the derivative is 0, that's a critical value, right? And when you have a critical value, what does that mean about f? Well, we'll come back to that. Well, actually, when f prime has a critical value, what does that tell you about f? It has a what? Good. More, though? Starts with an R. No. It has a relative extrema.
What?
Not always. So I want you guys to be aware, just because f prime touches that x-axis, that means f prime equals 0 for sure, which means it's definitely a critical value. But remember, just because it's a critical value doesn't mean necessarily it's a relative extrema. It could be. And I'll show you how you can know that in just a second. Now, let's go ahead and take a look at the top half here. And I would highly encourage you guys to label these things on your graph as you go as well. What do we know about f prime over here? No. It's positive. So I'm going to write it like that, right? Now, when f prime is increasing, what does that tell me about f? No. When the derivative, which is the slope, when the slope is positive, what is f doing? Going up. Fancy word is increasing. I'm going to abbreviate that INCR just because I don't have much space. But it's, so when f prime is greater than 0, f is increasing. And what about whenever down here f prime is what? No. What is f prime? Huh? Less than 0. When f prime is less than 0, what does that tell you about f? Yes. So, here's what we know then. We know that this graph goes from f. We know that f is increasing at first, and then it's decreasing. And it reaches a place where the slope is 0. So, if you're going from increasing to decreasing, it must be what kind of relative extrema? That would be a max, right? So you could tell by looking at the graph, since it goes from above to below, the f function will have a max. If it was reversed, if it goes from below to above, that means it's going from negative slope to positive slope. In other words, from decreasing to increasing, that would be a minimum. Okay, so let's go ahead and draw this. But these labels are helpful. So the first thing that we're going to do is we're going to put that 2 on our graph, right? Now, what's going on the left side of that 2? What's going on with f? No, it's not going above the x-axis necessarily. All we know is that it's increasing. So I'll draw it so that it doesn't. Watch. I know that it's increasing until we get to 2. What happens at 2? It reaches a 0 slope. What happens after 2? And so you were right earlier. I think one of you girls back there said it was going to be a parabola. You're right, because you're making the connection to yesterday's lesson. But I don't want you just to match the shapes together, which is helpful for shortcuts. But you got to think about all those details, right? When f prime is above the x-axis, f is increasing. So the green part over there matches over here, right? And the pink part over here, where it's below the x-axis, is where f is decreasing. Okay? And notice that the relative max is at x equals 2. Now, this is something I want you guys to write. You don't have to do this on your homework, but you do have to do this on FRQs a lot. So I want you guys to draw an arrow from here and here, and I want you to write a sentence. I want you to say, since f prime goes from what to what? Positive to negative. F has a relative max.
How come you don't put it? How come you put it somewhere below?
To prove Mateo wrong. But
Yeah, he does that one.
all that matters, because Mateo said he thought that meant it goes above the x-axis, and it's not. All that matters, you guys could have drawn your picture like this. That would have been totally fine. We don't know how high up this thing is. All we know is that from here to here it's increasing, and from here to here it's decreasing. We have no idea what the height of this function is. That's the plus c. Remember when you integrate, when you go from a derivative to original, you integrate, you get a plus c. And what does a plus c do to a function? It just shifts up and down. So since we don't know the c value, we have no idea where that actual line is. We just know its shape, and we know where its max is at. It's at x equals 2. Yeah.
So on our homework, it doesn't really matter like how high we go.
Nope, it does not. Not at all, because you can't know it. So on your test, it's going to be multiple choice, right? They're not going to give you 2 of these. with different heights. There would be no way to know the answer, right? They might give you two parabolas, but the difference would be like one would have a max at 2, and maybe the other would have a max at 3, and you'd have, or -3 or something. And you'd be like, well, obviously it's not the -3 because we know it maxes out at 2, because you can know that. But all right, let's go ahead and throw another one of these at you here. This is for you to do. You guys ready? There you go. That's f prime. I'm going to say this happens at -3, and I want you guys to draw f. I want you to explain it in terms of f prime. So to explain why this is a minimum in terms of f prime, you'd say because f prime goes from negative to positive at that point. Okay? You can't say because it looks like a U shape. They won't pay for that. I know that you laugh, but it's obvious. That's the instinctual thing that people want to do. They don't accept that. You got to describe it from the original function, the one that they gave you. And that's actually kind of a general rule of thumb. Any explanations you give should be coming from the function they gave you, not from the stuff you derived. All right, let's go ahead and continue, taking it up a notch. Example 3.
Yes.
What's coming up? You guys know? So we're going to call that -2. We're going to call this +4. All right, so I'm going to let you guys kind of walk me through this one a little bit. So that's the graph of f prime. I want a graph of f now. All right, so I'm going to call on you. Do your best. If you don't know, you can just say pass, and I'll take a volunteer in your place. But Angie, where does f prime equal 0? At -2 and 4. All right. Andrew, how would you describe f prime here?
It's the slope is increasing. Slope. It's negative, but it's increasing.
You were partially right in your answer. So I'll give that to you. Does someone want to give me a little bit more of a full and complete answer on that? What do we know about f prime there? It's greater than 0. Thank you. So if f prime is greater than 0, what do we know about f? Well, don't say it. Let me call on somebody. Sorry. Jonathan, if f prime is greater than 0, what do we know about f? No, it's not quite. Positive slope, which we're just going to use the word increasing. So I'll put an upwards arrow. It's increasing there. Zarina, where else is f going to be increasing? Because it increases somewhere else as well. So f prime is greater than 0 here as well, and therefore that's another place where f will be increasing. All right, Thea, how would you describe f prime here? Listen to my question. How would you describe? It's okay. I'm not meaning to pick on you, but everybody's doing this. Listen to the question. What does it tell me about f prime? It's less. So I know that f prime is less than 0, and I know that because it's below the x-axis. Now, listen to my question, Savannah. What does that tell me about f when f prime is less than 0? Decreasing. I'll just put a downwards arrow. Okay. Now, fun question. Ready? Amanda, would this be a minimum or a maximum? How come? I like your explanation, but your explanation doesn't match the graph. So you would be right. If it went from negative to positive, that would be a minimum. But remember, we go to from left to right here. So we're going from a positive slope to a negative slope, right? The green is above and below. So f is increasing, and then it's decreasing. That's a max. Okay? This one would be a minimum because moving left to right, we have a negative slope, and then passing that point, we have a positive slope. So that's negative. Okay? All right, so let's go ahead and graph it. We're going to put our numbers over here, -2, +4. I know that f is increasing. Does it matter where I start? No, it doesn't. So I'm just going to start here, and I know it increases until I get to what? 2. And then what does it do after 2? It decreases until I get to what? And then what does it do after 4? There you go. All right. Student practice. That would be funny. Vivian, draw me a picture. I expect beauty because you're an artist, so let's go. Up.
What if it's pretty, but if it's not right? Say 9:30. Oh yeah.
What if it's pretty, but not right? That describes Mateo. What? Pretty, but not right.
That's probably wrong.
You're actually very close to right. There's one switch I would make. Your maximum, this point right here, Vivster, I would have had the maximum be over the 5 like that. Because this number is where the maximum should be at. But other than that, you were good. All right, so any questions?
No.
What time do we get out, Mateo?
9:16.
What time is it?
8:56.
Oh, that's beautiful.
No, it is 9:10.
Shut up. All right, now look, I've got to edit my film, jerk.
You look like editing.
I might as well just start cussing now that I've got to cut it out.
Please, wait, no. I'll record you.
All right, we are switching. No, we're not.
Are we doing another one, or is this example 4?
We have a lot. So
But is this example 4? Or?
this would be let's call it a guided practice. All right, this one's different. This one is different. So this is f prime once again, and I want you guys to sketch a graph of f. So guided practice. That means I'm going to let you guys walk me through it a little bit. Mateo,
Yes.
what do I need to do first?
You need to look at where f prime is above the x-axis and to the left of the point, right? Yeah.
You have good things there, but your thinking's a little muddled, but I'll still give you credit for that. Someone want to tell me a good place to start here? We want to find our critical value. I like the vocabulary, air 5. Good, nice job. Where's my critical value?
2.
It's at 2. Okay, what do I know about f prime? Gabriel, I didn't call on you today, did I?
He's like, yo,
You need a card.
Oh, what?
All right, Gabriel, what do I know about f prime to the left of my critical value? Okay, so f prime is decreasing, but that's not what I want you to say. What else do I know about f prime? Is it greater than 0 or less than 0? That's what I want. It's greater than 0. Because it's above the x-axis. So f prime this is a graph of f prime, right? And since it's above the x-axis, f prime is greater than 0. So now, let's see, greater, and if f prime is greater than 0, what do I know about f? Good, so I know that f is increasing until I get to 2, right? So let's just draw that now. F is increasing until I get to 2. Now, let me ask another person here. How about Caitlin? What do I know about f prime to the right of 0? It's still greater than 0. Interesting. So what does that mean, James, if f prime is greater than 0? What does that mean about my graph of f over here? It's still increasing. But what happens right here? My slope has to be what? 0. Can you guys finish? I'm going to ask someone to come up here now. Can someone finish this graph so that I have a 0 slope, but it's still increasing? Caitlin, come on up. Good job. Thank you. She's right. All right. So right about there, it should you would consider having like a flat slope, right? Yeah, we would want to make it maybe that was my fault really. Maybe more like this. That way we end up with a flat slope there, but it does keep going up. All right. So that's kind of a weird little exception to the rule. Let's go ahead and 9:56:16. We got time. We're going to keep going. All right. F double prime.
Another guy in front? Oh, no.
This is example what, Mateo?
4.
Okay, example 4. This is f double prime. I want you guys to draw a graph of f. Now, I'm not going to ask you guys to draw a graph of f prime because going from f double prime to f prime would be exactly the same thing that we just did. That's the same thing as going from prime to no prime. You're just going up a level. But now we're doing something different. We're skipping a level. We're going straight from a second derivative to a no derivative. Okay? So, what do I know about my second derivative? It's constant. And what else? It's positive. So, what does that mean about f when your second derivative is positive? I couldn't hear you, but no. It doesn't mean it's above the x-axis. Now, f double prime is above the x-axis. That's how I knew it was positive. But I need more. So what does this tell me about f, though?
It's concave up.
Okay, it doesn't. That's the answer I want to, but I'm going to say what Pearl said, too, because it's important. Pearl said if f double prime is greater than 0, that means that f is increasing. That's not necessarily true. It means that f prime is increasing, the next level up, right? Because this is the slope of f prime. So if the slope of f prime is positive, then f prime is increasing. But that's not what I'm asking about. I'm asking about what does it tell me about f? And what this tells me about f is that f is concave up. Yep. Is it ever concave down? Not on this one, it's not. So what kind of shape am I going to have? Probably a parabola. It doesn't have to be, though. It could be any shape that's concave up. It could be an exponential function. Those are always concave up, too. So I can't really give you what the graph looks like. I only know it's concavity. So these questions are multiple choice. You can only pick the one that matches the information you know. Because there's really a bunch of ways that could happen. But all we know is that it's concave up. Okay? So, this one you don't need to write down. But this is f double prime. And I'm going to have a person come on up here and draw for me what you think that would look like. Who's feeling bold today? Who would like to draw me the graph of f? If this is f double prime, I want to know what does f look like.
That's the same thing as last problem, right?
Maybe. Mateo, come on up. I don't want to give any secrets away.
Go away.
Just like.
Great, thank you, sir. That's it. Second derivative is less than 0, therefore f would have to be concave down. That's all we know about f, is that it's concave down always. Okay? Thank you. I feel so good about myself when you do that. All right, example 5. Who can tell me what I'm going to draw now? No. No. Yes. I'm going to draw this. This is F double prime, remember? This is F double prime. Excuse me. I look like I like horses? I like all of God's creatures. They're beautiful. Even the coronavirus. I wish I could pinch his little minuscule cheeks.
Were you killing people today?
Okay, back to
Okay, you guys ready? What's happening here?
It's touching X. Or X is a critical value.
It's not a critical value.
F double prime of X. Yeah.
Go ahead.
Who, me?
Yeah.
I don't know.
Okay.
Oh, is it equal is 0?
0. Now, when F double prime equals 0, that point could possibly be a, don't say critical value, point of inflection. Critical values for F prime, okay? F double prime gives you points of inflection. All right, what do I know about F double prime over here?
No, it is greater than 0.
It's above the x-axis, which means that it's greater than 0.
Curl.
Now, if F double prime is greater than 0, what do I know about F?
It's concave up. Concave up. Right.
Oh,
Now,
it's double prime.
if over here, what is F double prime over here?
Less than 0.
I hope you guys are writing these little notes down.
Of course we
If
are.
F double prime is less than 0, what do I know about F?
Concave down.
All right,
Now do it.
ready?
No.
I'm ready.
I need to draw a function. I didn't give you a number. Let's call that 1, okay?
A word.
I'm going to give you a graph, and you guys need to draw me a graph that is concave up until it gets to 1, and then it's concave down. Okay? Who would like to bust this one out for
Am
me?
I right? I'll do it.
I think that could work. Come on. Yeah,
Do it,
let's
Cole.
do it.
Slide.
Concave up until you get to 1, and then it's concave down. All right. Vamos a hacer un otro más. ¿A qué hora es?
We have to write this one down.
Sí. Example 6. I hear folders snapping. You better not be packing up.
No. No.
Someone will perish if I hear you packing up.
Pack up.
I have a vial of the coronavirus in my pocket right now.
Oh my
I'm
goodness.
not afraid to use
Or?
it.
So that's what we're doing now.
I hope it doesn't make its way over here. I shouldn't joke. It's pretty
It's in Orange
serious.
County.
It's in Orange County.
I know.
It's fine.
He's a
Yeah, Mr. Bailey. We all get tickets here.
Pay attention.
One of these days, yeah. Yeah. A little wet in there.
I thought you that was such a horse face.
All right. Let's see. So, Serena, tell me something you know about this. Tell me anything you can figure out about this graph. Remember, our goal is we want to graph the original function. So tell me something you know. Very good. She's right. Between 2 and 6, we know it's concave up. Right? Well, watch my language here. It's concave up. What's concave up? F. F is concave up. So since F double prime is greater than 0 above the x-axis, F would be concave up on that interval. And so obviously, what do we know about over here then?
Concave
All right, see if you guys can sketch it. So here's what's going to happen. My graph is going to be concave down until it gets to -2, and then it's going to start bending up. And then it's going to do that until I get to 6, and then it's going to bend back down. See if you can graph that. I'm going to try to spread the love a little bit, but if nobody else wants it, I'll move. Matter of fact, I owe you a point for the last. Who thinks they can draw this graph for me? You can't? Or you don't want to? Okay. Alright, I want to peek at papers before I call for a lift. What do I know about F? F. What do I know about F to the left of 2?
Concave down.
Okay, so you guys got to know what concave down looks like. Concave down looks like that, right?
Yes.
That's bending down. Now, what do I know about F between 6?
Concave up.
Concave up. I got to keep going here. And what do I know about F to the right of 6?
Why'd you go so far up? Oh, you're so wrong. Why'd you go so far up?
I just did it.
Huh?
But why wouldn't there be
What are those points?
point of inflection?
I think I got my point of inflection a little bit off here, but I'm close. Now I don't think this is the only way this could have been drawn.
I don't think so. I think
Let me show you another way this could be drawn. Concave down, right? Right?
Yeah.
Concave up,
Yeah.
concave down.
We were right.
Okay? So there's other ways to draw it, because concave down could be like this or like this.
So it could go both
We
ways.
were